Hello everyone, welcome to our second workshop in our 3-part data science series. Before we get started, can I see a quick show of hands? How many of you were there for our previous workshop last week? Okay, so it's about 50-50. Okay, that's nice. Even if you guys weren't there for the previous workshop, don't worry. As we go through this workshop, we'll be revising some of the topics we did last week, so you won't be lost. So last week we learned the basics of data science and data manipulation and some of the libraries that we use, like pandas and Simeng. In today's workshop, we'll be going a bit more in-depth towards machine learning and how we can use machine learning in real-life applications. So before we get started, if you have any doubts during the workshop, please raise your hands and our committee members will come and help you out. We want you guys to enjoy the workshop, and if you're lost on the first step, you won't enjoy it. So please don't be shy, just raise your hands. And second of all, if you have any questions for the speaker, we'll be having a live question and answer session in the middle of the workshop as well as the end of the workshop. So we'll be doing this through Pigeonhole, so you can scan this QR code or go to this link and you can ask anonymous questions to the speaker. That's about the question and answer session. So today's workshop is being given by Simeng. She's a third-year undergraduate computer science student in NTU. She has a lot of experience and a lot of knowledge about AI, machine learning, and data science, especially natural language processing. I've gone to loads of hackathons with her and loads of competitions. And whenever our team has any problems with like any machine learning problem, she always saves our asses. So I think you guys are in good hands today. So without any further ado, let's have a loud round of applause for Simeng.
Good evening, everyone. Can you hear me from the back? Yeah, okay, great. Now, thank you guys for coming to the second workshop of OSS of the data science series. So we have 3 workshops in the series, and in the first workshop we basically talk about the data cleaning and manipulation. And in the second workshop we will talk about some more techniques about data analysis. Yes. And in this
is it connected?
Wait, which one did you pick? Notification, right? Improve 3T.
Okay, so at the same time, can we have a quick show of hands? How many of you would like to learn more about coding, and how many of you would like to basically know how it is going behind, besides knowing how to make this work? You want to know what this code means exactly, and also some math behind. So those who want to know the math behind, please show your hands. Okay, almost everyone. So in this workshop, we will not be talking every detail of mathematics, but we will give you enough mathematical intuition to let you understand the algorithm.
How to get it on the screen? Here it is. Display.
Yeah.
No, it's on here, middle.
Okay. So if you guys have scanned the QR code on the workshop material, you'll be directed to this page. So this is the GitHub repository for today's workshop. If you have found any errors in these materials, please feel free to post an issue or talk with me. Yeah, so today we will be talking about machine learning with sklearn, and in the workshop today we will focus on the practical aspect, but since a lot of you want to know the math, I will also talk about them. Now, let's get started with our data Odyssey. First, let me give you a short introduction on what is machine learning. It is an interdisciplinary subject where computer science and statistics intersect. And in the workshop today, so for the traditional algorithms, we give it an input and it will give us an output. But for machine learning algorithms, we give it an input and the model will try to learn the parameters which should fit well with this data. And then when we give it an input, you will be able to predict the output. This is the process of determining the parameters of the machine learning model and also the prediction. Now, there are mainly two categories of machine learning, supervised machine learning and unsupervised machine learning. In the supervised machine learning, we feed the input and the label into the model, and it will learn how to predict the output. Think about it like a teacher teaching you how to do while giving you the correct answers. But in an unsupervised machine learning, it will be like there will still be a teacher, but it doesn't give you the correct output. In the real-world setting, there are a lot of data which don't have labels, which is just like the case where we have to learn without a teacher side by side. So the unsupervised learning algorithm is also necessary. So here, the two links here are the documentation for sklearn for these both algorithms. So if you want to know more about the parameters, you can go to this documentation. For today's workshop, we will use the Google Colab tree and now let's set up the notebook and also the data in the Google Colab. First, let's click on this link, notebook. Okay, is everyone on this page? So if you have any questions, please raise your hand so that our club members will go to help you. Yeah, so if everyone is on the page, we can now save a copy of this notebook in our Google Drive. So it's creating a copy and yeah, so it's saved in my Google Drive and we will be able to run the code here. Has everyone copied to Google Drive? Oh, please raise your hands if you have any problems or any issues. If not, then I will continue.
Tell them to raise their hands if they're done.
Yeah, also please raise your hands if you are done. Okay, so we will continue by uploading the files. So in the GitHub page just now, if we go back to it here. So here, as we can see, here is a link on the data that is going to be used. If we open it, we'll find a cat image and a series of data, and we can download this data. Yeah, after you have downloaded this data, please upload it here. So as we can see, yeah, so it's downloaded and unzip it. Then we can upload the files here, the data. So upload them one by one. Is everyone done with this part? Or does anyone need help? Please raise your hand. This part is crucial because you have to put the data in the right directory, otherwise you will run into bugs later. Just in case anyone need to catch up, I will repeat it again. So we click, after downloading the data, we click this upload link and find the data where it is located and upload both of the files to our drive here. Okay, is everyone good to go? Yeah, so I guess most of you have done. Now we can begin our supervised and unsupervised data Odyssey. So in supervised learning, we have this classification and regression algorithms. And in unsupervised learning, we will introduce a clustering algorithm. Here's the table of contents for today's workshop. We'll first set in supervised Odyssey, we will set up the environment, do some data exploration, inspect the data, and then run the logistic regression algorithm on the data. And finally, visualize the result. And in Unsupervised Odyssey, we will introduce a topic called K-means, which is an unsupervised clustering algorithm, and we will use it to do image compression. Finally, is the result visualization. Okay, so we will now start coding the supervised classification first. So let's first set up the environment by importing the necessary library from sklearn. So you can code with me from sklearn linear model. For logistic regression. Logistic regression is a module in sklearn. And after we import it,
most people are just clicking on the link and going with that collab. Tell them that they have to make a copy on their Google Drive.
Okay, so some people just click on the link in the GitHub repository here, but we need to copy this notebook to our Google Drive. So as we can see here, under the data Odyssey, there's file, and click on Save a Copy in Drive to save it in Google Drive, because otherwise we cannot run it. Yes?
there's some error.
Can we have a quick show of hands how many of you have copied this notebook to your drive? Okay, I suppose we can continue. Now we continue with this topic. So after importing the logistic regression module from Skiller, we can click Shift Return or Shift Enter to run this line of code. Okay, have you successfully run it? Yeah. Thank you. Yeah, after importing the logistic regression module, we also want to import the data visualization libraries like matplotlib and NumPy. So to import this, we also click Shift Enter to run this code. Have you successfully run this blog also? Okay, then we can continue to do the data exploration. First, we need to load the data from the file, and we can code here by deleting this comment sign. We load the data with the function in NumPy, which is called numpy.loadtxt. So loadtxt is a function that loads the files in the txt format. Since our data is in the txt format, we can load this data. And in this data, we actually has a delimiter which is used to separate the data, which is a comma, and we can set the delimiter here. After loading the data, we can inspect the data by first seeing how many rows of data we have. The number of data is equal to the shape, the 0 dimension of the shape of the data. And then we can print the number of data. Now let's click on Shift Enter to run this code. Oh yeah, so since the directory should be data.txt, so yeah, we have run this code and it prints out the number of training data is 100. Does anyone need help or is there any questions? Okay, then we can go on to print more details. I'll not explain this code by detail since we have a data preprocessing section last time, but let's print out this data. So as we can see here, this part is the first 10 rows of the data. Basically, it has the first column is a number from 0 to 100, and the second column is also a number from 0 to 100. And the third column is what we call the label, so it's 0 or 1 here. And for the data we are using, let's say the first column is the exam grade 1, and the second column is the exam grade 2. And the third column represents whether a student is admitted or rejected. So as we can see here, if the two scores are both very high, as in the fourth row, the student will be admitted. Now let's go on to plot all the data. Yeah, so in this part we use matplotlib plot function, and in the training data, as we can see, the red points are the students who get admitted, and the blue points are the ones who get rejected. Has anyone been in the same page? Okay. Now, for those who have done, can you see any specific pattern from this data? Does anyone? Yeah, so basically there is a line here. We can roughly see a line that between the admitted points and the rejected points. So this line is what we want to predict finally, and this is called a decision boundary. So has everyone been able to plot this graph?
Tell them that if they can't remember any code, or if you're going too fast, they can see the code in the README.
Oh yeah, and if any of you thinks I'm going too
Can you go up
fast,
a little bit to show the code?
yes.
Because some of them have lost the code. Yeah.
Okay, so if any of you can't follow, you can see the README for the details of the code. But this part is already typed in the notebook because this is a data pre-processing and data inspection, which we talked about last time. So today we'll be mainly focused on the machine learning algorithms. So this part we will just run it and see if we can get this graph.
Can you show them the README and where the code is?
Yeah, so if you didn't catch up, please see the README here in the GitHub page. So in this README, we also have a detailed explanations on every line of the. Okay, well, some of you are still figuring out how to plot this. Let me first explain to you why this data has such a specific trend. So in the real world data, we actually it's not quite easy to get such patterns because there are like dirty data which can be wrong values that are recorded. So it's recorded by people and there are sometimes errors. But this data is already clean, so we can see a specific kind of boundary here between the blue points and the red points. Okay, so let's continue with the algorithm part. Now we will try to classify this data with the algorithm called logistic regression. Let's first take a look at this online demo by clicking on this link. Is everyone on this page? Okay, so as we can see here, the green dots are the data points, while the black line is the line produced by logistic regression to fit this data. So last time we talked about linear regression, which produces a linear line to fit the data. But in the real world, not all of the data has a linear property. So we also need some non-linearity in it, and this is why we use logistic regression. Now we can play around this dot. So as we can see, when the data points moves, this logistic regression line also moves. Yeah, so this is basically how the model learns. As we can see on the left here, this function is the logistic regression function, and these parameters, A, B, and T are the parameters, which will change as we change the data points. Okay, so after playing around with data, let's go back to our code. So has anyone had a intuition about what logistic regression is about? Or do you have any questions on logistic regression? Okay, so now let me give you a formal introduction to logistic regression after looking at the intuition. Logistic regression is used when the variable is categorical. So categorical variable means we want to find a class for each of the variable it belongs to. For example, if we want to classify spam email, we find a class for the spam and we find a class for the normal email. Now here is the predictive function for logistic regression, and as we can see here, the x are our data points, the values of data points. Each of the dimension of x is a feature, and each of the w is a parameter, and it's also called a weight, which gives x a weight. And finally, with this sigmoid function, it will produce a probability where produce output for x, and here is, and in this case, it is a y value on this line. Now, as we can see here, we could have several dimensions of x, and so here we have 2 dimensions for x, and we have n numbers of data. So in this graph, we can also see a clear distinction between the logistic model and the linear model. In the linear model, we have 2 parameters here, and in the logistic model, we have exactly the same 2 parameters, b0 and b1, but we have an exponential here, which makes this line into a nonlinear line. Okay, so now we have finished the mathematical intuition part, and let's get into the model. First, let's code this function. So this function is called this function that gives the original linear model nonlinearity is called sigmoid. And let's code this function. So the sigmoid value is equal to, we can code according to this equation. And we will use the exponential value from numpy here. So z is what we can see here that we get from the linear model, and we put it into this sigmoid function to produce the sigmoid value. And in fpredict, we use x and w instead of z.
The font is too small.
Okay, so let me scale. So final output will be the sigmoid value of x, the dot product between x and w. So in dot product, we time each of the each row of x with this column of w. Okay, after this we can run this function by clicking on Shift Enter. Okay, after coding these two prediction functions, let's code the logistic regression model from sklearn. Let's first create a logistic regression object. Logistic regression from sklearn. Now recall the module we just import from the SE library called Logistic Regression. Now we have a logistic regression object, and after this we can feed this model, feed the data into this model by so we use this object to feed the data. Now, before we run this model and run the training process, let's first create a parameter for storing the weight of the scalar.
Too small.
Okay, I mean scalar. Now this represents the parameters this model learns for scalar, and in this case, in the first row, first column, we will store the intercept. So the intercept is this B0 value here, or we can see is this W0 here. And next, let's store the other parameters into the coefficient part. Now let's run this code to train our model. Okay, after this is successfully trained, we can visualize our results. So as we can see here, x is the data, and we use this prediction function to predict with the x values and the parameters from sklearn, we can predict the y values. After predicting it, we will now plot this decision boundary we have predicted with the sklearn model. So if we run this code, we will get a specific decision boundary. So this is what our model has predicted. Below this line will be the students who get rejected, and above this line will be the students who get admitted. Okay, so if now we think about what we have done with this logistic regression object, we have feed this model into the data, and after feeding the model into the data, we get the parameters. And after getting the parameters, we can plot the decision boundary, which is what we use to predict, or whether predict the unknown data which we feed in later. So now we can feed in any exam grade 1, exam grade 2 to predict the category the student will belong to, whether he or she is admitted or rejected. Now let's try to predict the probability of the student's admission. Recall the prediction function we just called.
Simeng,
Yeah.
just ask everyone if they're following through. Like, if anyone's stuck, just tell them to raise their hand. Do
Okay. So is anyone stuck at this point? Please, yeah.
Oh, scroll on. Oh, scroll up. Scroll up. Higher. Okay. Ask again. Is anyone stuck?
Okay, is anyone still stuck? Okay.
Okay, yeah, continue.
Okay, we'll go. Yeah. Now let's predict the probability of the students get admitted. Now this one here means the student gets admitted, and this 45 means the exam grade 1, and we will choose another value, say 85, which is the exam grade 2. And we need to feed the parameters we just learned, the weights from sklearn, to predict. Now let's run this code. We'll see the probability of students getting admitted is 0.774. Yes? Oh, so 1 stands for students get admitted. So if we recall what our data looks like here, as we can see here, the labels are 0 or 1. 0 means getting rejected, and 1 means getting admitted. So we want to predict if a student will get admitted in this case, so we put 1 here. And the 45 and 85 are the exam grade 1 and exam grade 2, the x and y axis here. So in this case, we want to predict if a student will get admitted if he gets 45 and 85 exam grades.
Pigeonhole now?
Okay, so does anyone want to try another value? Okay, so let's say the student has a specifically high exam grade. The probability of admission will be pretty high. As we can see here, it will be in this region. Okay, so this is our supervised classification algorithm using logistic regression. Now let's have a pigeonhole session if you have any problems.
Okay, hello everyone. Before we do the pigeonhole session, I just want to get a quick feedback from you guys. So can you just raise your hands if you don't understand what's going on or if you're lost in this workshop? Okay, so that's like 50%. Okay. So I'll just go through some of the points that could be like problems for you and just raise your hands if you're having those problems. So is the text too small for you? Raise your hands. Okay, a lot of you. Okay, the theory, you don't understand the theory that was just explained. Raise your hands. Okay, 4, 5. Okay, you don't understand the code that's being written down. A few more people. Okay, what other problems can there be? How many of you have just given up on coding and are you just listening to the workshop and like you try to do it at home? Raise your hands, don't be shy. Okay, so in the next part we'll try to like go a bit slow and make sure that you guys understand the code and the theory. So we'll just do the pigeonhole session right now. If you have any questions and doubts in the last section, you can feel free to ask those questions.
Yeah.
Can you choose the question that you want to answer?
Not necessarily what I said.
Okay.
Even now I can change to another one.
Wait, what happened? Ask.
Okay.
Select the top question. No votes.
Okay. So someone has asked why I choose Skinner instead of TensorFlow. Because we are specifically learning machine learning algorithms here. So in machine learning, the computation is not that large, and Skinner has specifically packed machine learning libraries, and they are quite easy to use. But for TensorFlow, it's mostly for deep learning projects where we have a large amount of data and we have to code, especially very complicated algorithms like neural networks. TensorFlow will be a good choice in that case. So in summary, in machine learning we use Skinner, and in deep learning we use TensorFlow.
Moderate is unmoderated.
More questions are coming. Answer it. Another one.
Okay.
If you guys have any more questions, you can go to the QR code on the left and ask them right now. We'll have another question and answer session at the end of the workshop. You can ask them then also.
Okay, so someone has asked a question on the code. Now, as we can see here, in linear model, we get a value which is linear, and we put this linear value into the logistic model here. Now, the sigmoid function is 1 divided by 1 plus the exponential, the minus exponential of a number, and yeah, so this value will be C. And if we in this case, it's the product of X and W. So in here we choose V, but in here, since we have a lot of weights, we usually use this W to represent the parameters. So Z is the dot product of the parameters, the weights, and X. And it's also specified here in this equation.
How many questions do you intend to answer?
Yeah, so we will answer 2 other questions. Yeah, now let's talk about another question on the model part, the code part. Yeah. So someone has asked a question on the model part. So after we create a logistic regression object, we feed the data, And the parameters here, the intercept and the coefficient. And if we see here, there are some parameters that are timed with x values. There is also a parameter that's just itself, which is timed by 1 in this case. So the intercept will be this W0 and the coefficients is W1 and W2. Okay. Now the final question. How do I determine the regression model to use? That's an interesting question. So last time we talked about linear regression, which wants to feed the data into a linear line. So sometimes we use it to predict, say, some linear problems, like the numbers are more regular instead of in this case. So if we can go back to the demo. Now in this case, we can specifically see that the data has a kind of a weird shape instead of being linear. So in this case, we want to use a nonlinear model, which is the logistic regression, instead of the linear model. So for most cases, if the data is not linear, we use logistic regression. Okay?
You want to answer more questions? How do you determine the regression log which I just explained? So in the next section, we have the data relates to the equation, because something at a time we give the equation, but we don't know which part of the data is going to be which part of the equation. Also explain them, but just tell them beforehand how you'll be using it, like we're doing image compression. So you can say just you'll be doing image compression.
Okay, so now we're done with the first part, the logistic regression, and in the second part we will talk about the k-means algorithm, which is an unsupervised clustering algorithm. And more specifically, we will use this algorithm to do image compression. Firstly, let's take a look at the algorithm intuition of this algorithm. We click on the online demo. Now, in k-means, the k means the number of clusters we want to get. So we can see here, there are 1, 2, 3, 4, 5 clusters. And this number we actually set by ourselves. And we want to cluster each of the data points into its nearest centroid, which is the center of the cluster of data points. So we can change this cluster, say, into 6. And let's iterate the algorithm. Okay, so after changing the cluster number into 6, we now have 6 clusters for the data. And each of them is therefore classified into a type. So the difference between this algorithm and logistic regression is that here we don't have a specific class for it. Well, in logistic regression, we have a specific class, say 0 or 1, that we want to predict. Now, does anyone know what k-means algorithm does now? Okay, so now let's explain the k-means algorithm again. So first, let's see what its name means. So in k-means, k means the number of clusters we want to put cluster the data into, and means meaning we want to find the means of the clusters, which is also the center of the clusters. And then the data will, as we can see here, the different colors represent different clusters. Okay.
Could you explain, like, give an example of like what a cluster can mean? Like this can mean bad students, can mean good students on one test. This can mean good students on the test. Like give them an example of cluster.
Okay, so in here, these clusters could mean the number of students that have specifically high grades will be clustered here. Then those who are not as good will be clustered in another cluster. Or in other words, the data points that are clustered together are more similar to the points in other clusters. So it also represents the similarity. Okay, so now let's code with sklearn. First, I put the algorithm intuition first because some of you wanted actually to know it first. So now let's actually go back to do the data exploration. Now in this case, we want to read an image instead of some numbers. So we will use the imread library in the matplotlib. Now delete this comment sign. The image object will be
Zoom in.
So we read the image we just uploaded, and then we show the image with IMShow. Yeah, so now we can see this cat image here. Has everyone be able to see this image? Okay, yeah. Now, a 2D image is comprised of two-dimensional RGB values, which means instead of they are seen as an image, but inherently they are also numbers. So for each pixel, there are 3 numbers, red, green, and blue, and 2D image has rows and columns of pixels. If we print the image size, it will be 700 or 1003. So 700 means 700 rows, and 1000 means 1000 columns, and finally 3 means the R, G, and B values. Yeah, so this is just some background knowledge on image processing. Okay. Now let's do the image compression with k-means. First, we want to reshape this image into a two-dimensional data. We create an object which is reshaped. So we call the reshape function. The zero-dimensional image size is the row number, and the first dimension will be the column number. And the third dimension is the RGB values.
Zoom in.
Now, after reshaping it, we can run the k-means algorithm. We create a k-means object. We assign a number of clusters here. Remember the online demo where we could assign a number of clusters ourselves? And after creating this object, we will feed the data, which is X. Yeah. So actually we forgot to import the k-means library, so we want to also import it here. It's a clustering algorithm, so it's in the clustering category in Ascii, and for its name is called k-means. Now we can run this model. We can train this model here. So the image actually has a lot of data points, and it will take a bit longer than the algorithm we ran just now. And also the k-means during the clustering process, it has more computation than logistic regression. So we can wait a while till it finishes.
You can do command ++ to zoom in.
Now we can see here we have run the algorithm, and these parameters are the hyperparameters, which are by default these values are like this. And if you want to know more about these hyperparameters, you could refer to the Ascii documentation for the k-means algorithm. Now, after we have trained our model, we can use it to compress the image. So the idea here is that the image consists of a lot of data points, and we want to cluster these data points by similarity. So the number of clusters here will be the number of colors, and we will so the points that have similar colors will be grouped together and converted to one single color. And in the end, we will only have 20 colors for this image after we run the k-means algorithm. So does anyone understand how the k-means is related to image compression? Okay, good. Now, we can use the model we have trained to do the image compression. We use the object we just created here, kn, and we call the function clustering function. With the labels. Now let's run this code. Now the image has been compressed, which is this X compressed object. Now let's print out its shape. So as we just reshape it to that 2 dimension, it's still 2-dimensional here. But to do the result visualization, we actually want to reshape it back to the original dimension. Now we can call the reshape function x compressed is x compressed of reshape. We want to shape it to the original dimension, which has 3 dimensions: row, now column, and the RGB values. Yeah. Now, after it's reshaped, we can plot this image and the original image side by side to compare the difference. Now, to plot the the images, let's first define the figure and the axis. So we use the matplotlib library, and in this case we have two images, 2 plots, and we will use the subplots function. We define the size of the figure. And next, we use the IAmShow function from the matplotlib to show image. And the 0 index here means the first image, which is the original image. And the 1 index here means the compressed image. So after formatting the images, now we can plot it side by side by calling the tight layout, so that they will be layout on the same row. Okay, now we can run it. Yeah, so we have 2 images now. Has everyone been able to plot these 2 images? Are you good? Okay. So now we have compressed this image with 30 colors. Yeah, and as we can see, this image is a little bit more blurry than the original one. Then this is because it has less number of colors. Now let's go back again to the k-means algorithm. The 30 number of colors is the centroids the k-means gets from the data. So if we go back to this demo again, we can see that these centroids are the number of pixel points we have selected from the image. And the other pixel points will be the same as this point. Yeah. So that's the end of the second algorithm, the unsupervised clustering algorithm. Let's do a Q&A session.
You guys can scan the QR code or go to the link if you have any questions.
Oh yeah. Sorry. So there are actually 20 colors, but we can make it 30. So in this case, we have 20, and I type this one. Yeah.
Do you want to choose a question? Which one? This?
Cluster centers. Choose. I think you choose the clusters, but
I'm going to say it.
Yeah.
Active.
okay. So someone has asked what's the KM dot cluster centers do. Now, as we can see here, we have created a k-means object, and we feed the data into this model. After feeding this model, model is trained to be able to predict the clusters, the data points belong to. So this is the prediction function, which predicts the cluster centers. So it will return the 20 number of data points, which is the 20 number of colors we will use for the image family.
Can I explain how the function that explain more of predicting?
Okay, so as we can see here, the centroid is this from this X compressed, and yes, this is which is predicted by this function. We can actually try to print this X compressed. Yeah, so as we can see here, let me first comment this out. This would be the data points. So for each data point, for each clusters, it will have a number of similar data points. So as we can see here, there are a number of 184, and there are also a number of 184, 184, 184, 181 images. This stands for the R, G, and B value. And this is another centroid, which is 194, 194, and 190. Now, so this clean function just makes this into integers. Yeah.
This has all the results, right? This has all the results, right?
Yes, this has all the results. Also, someone has asked me to scale up the result visualization part. So yeah, we can take a closer look at it. So in here, we want to plot two images side by side, and this tight layout does this by plotting them on the same row.
So we're getting loads of questions asking to zoom in into some code or like show some results. If you guys are unable, like if you guys are lost or if you want to see some code, if you go to the GitHub repository, there's an IPYNB file called data_Odyssey_finished. So if you open up that file in Collaborate, you can see all the complete code and all the complete results if you missed anything.
Okay.
Okay, now let me give the conclusion. So we have covered two algorithms, one supervised algorithm and one unsupervised algorithm. And congratulations on finishing your perhaps very first machine learning journey, and I hope you have learned something. Now in this workshop we try to solve simple problems with machine learning, and in the next workshop of the OSS workshop series we will touch on deep learning with neural networks, and which is more interesting. Now just to give you a quick dig into the next section. So artificial intelligence is a large field, and machine learning is part of the artificial intelligence, while deep learning is a part of the machine learning. And this deep learning, which is the topic we'll talk about in the next section. Now, if you want to learn more about machine learning, you can also read this book, which is called a first course in machine learning. Now, let me go to this website. Or I can just search for a course in machine learning. Yeah, so this is a free book which you can read more on machine learning. So that's all for the workshop. And if you have any other questions, you can always come down to ask me, or from my GitHub you could send me an email or send me messages.
Okay, thank you, Simeng. That's the end of our workshop. Let's have a round of applause for Simeng. Now, so undoubtedly you guys still have lots of doubts and you didn't understand some of the parts of the workshop. So we've done a live recording of this workshop and we'll be uploading it to our YouTube channel. You can scan that QR code and go to our YouTube channel. We'll also be uploading a Medium article with all of the details and all of the descriptions about the theory and the practical sides of today's workshop. So you can go on our Medium page and you can check out the article we'll be posting about day after tomorrow. And you can also subscribe to our Telegram channel to find out about our other events and the links to our Medium articles and our YouTube videos. So those are the links. I'll come back to this slide. Before that, I'd like you guys to fill up your feedback form here. It would help us out a lot. So if you guys like the workshop or didn't like the workshop, we'd love to hear your opinion. So please scan the QR code in the middle and give us your feedback. Thank you guys for coming tonight. Thank you.